Hey 7th graders, this is Mrs. Cervantes.
And Mrs. Salati.
And together we are
Mrs. Servati.
Okay, take out your notebook. You are looking for your blue note taker that says 1.3 subtracting integers. So we just finished adding integers with same signs, adding integers with different signs. So now we're going to look at subtracting integers. If you look at your essential question, it's just that you can subtract integers. Find your key terms. Opposite of the number is your only key term for today. It says two numbers that are an equal distance from 0 on the number line. They are also called the additive inverse. So if we look at a number line and we're talking about opposite of a number, let's say that's 0, 1, 2, 3, negative 1, negative 2, negative 3. Super sloppy number line. But if we're looking at opposites, we're looking at 3.
Evan Boggs, please come to the office.
And we're looking at
Evan Boggs, please come to the office.
Negative 3. Hopefully they find Evan Boggs by the time you hear this video. Okay. So you're the equal distance from 0 on the number line. So I'm 3 spaces away here. And I'm 1, 2, 3 here. So 3 and negative 3 are opposites. So opposite of 3 is negative 3. Opposite of negative 3 is 3. Do not confuse those with absolute value. Okay, those are also called additive inverse. So if I was doing that, I could say negative 3 plus 3 is equal to 0. Okay, all right.
All right, 7, 8 students, you got to bear with me because this is the why. So this is going to lead you into the rule and why the rule works. So I want you to really pay attention to the language and why I'm doing the things that I'm doing. So we are going to model with chips, okay? And I know that many of you are probably like, why? But again, this is why the rule is, which Mrs. Cervantes is going to cover on the next slide. So for this, I want to review. 0 pair is 1 yellow and 1 red, okay? And in order to start this problem, you're going to look at your first number to represent your first set of chips. So if you guys notice, I have a positive 4. So I'm going to show you my 4 yellow chips, okay? Now with subtraction, this is where I'm going to slow down and really focus. I want you to tell me or think to yourself, can I take away 3 reds? Okay, because subtraction, when you guys first learned this in kindergarten first, was basically like, here's 10 dinosaurs. Can you take 4 dinosaurs away, right? You physically remove them from the table or whatever. Your question is, because it's subtraction, can you take away 3 reds? And your answer should be no. Okay, so follow me. What we can't do, we will create. So I'm going to take this 3 and I'm going to create or add in 3 0 pairs. So let's go 1, 2, 3. And I have to, if I add in yellows, I can't just add them in because I want to. I have to justify it. So when I add in 0 pairs, it's really a 0 value, right? But now your question is, can you, since you added in those 3 0 pairs, can you now physically remove or cross off on your paper 3 reds? And your answer should be yes. And then now you can see that I have 7 yellows, so my answer is a positive 7. Okay, again, if that was kind of gibberish, you're like, what's happening? Follow me on this. So now I look at my second problem. I'm going to represent my first set of chips. So I have, make sure these are yellow, 1, 2, 3, let me space these a little bit better. 1, 2, 3, 4, 5, and 6. Can I, when you ask yourself, can I take away 3 reds? The answer should be no, because there aren't 3 reds to take away. So if it's not there for me to take away, I'm going to create it using 0 pairs. For every 3 yellows that I add, I'm going to add in 3 reds. And then again, now can I take away 3 reds? And I can, 1, 2, and 3. And now you can see that I am left with 1, 2, 3, 4, 5, 6, 7, 8, 9 yellows, which is a positive 9. Okay? And the next one, and you should be writing or representing the chips in your note taker as well. The next one, I look and I have 2 reds. So I'm going to start out with 2 red chips. And again, you ask yourself, can I take away 5 red chips? And I can't, right? I can only take 2 away. So you think to yourself, how many 0 pairs do I need to add in order to be able to take 5 reds away? And if I add in 3 0 pairs, So I'm going to go 1, 2, and 3. Remember, for every 3 that I add in red, I have to add in the yellow to make them 0. And now, can I physically take away 5 reds? I am now left with 3 positive. So hopefully at this point in the game, you're starting to look at these math problems and identifying why we are getting up here a positive 7, why we are getting the positive 9, and why we are getting a positive 3. Again, Cervantes is going to cover that in the next slide with the actual rule. Last problem, again using the chips. I'm going to erase these, so hopefully you have them all written down. I'm going to represent my first set of chips, which is 1, 2, 3, 4, 5. I ask if I can take, whoa, you knew that was going to happen at least once in this video. Can I take away 8, these are now 8 yellows, right? Because the takeaway is my subtraction. So you say, nope, I only have 1, 2, 3, 4, 5, so I need to add in 3 0 pairs so that then I have the 8. And now can I take away 8 yellows? I have 1, 2, 3, 4, 5, 6, 7, 8. In this case, I am left with a negative 3. So again, start to look at these problems and identify where those numbers came from. Do you want to add anything on the chips?
No, but just leading into the chips, take your time, because I even struggled with this when we started using the chips. So take your time, go slow doing them. You're going to get frustrated, but rewind the video. If you have questions or you don't get it the first time Miss Talati does it, rewind the video and watch it again. And I guarantee if you watch it again, certain parts of it will start to click, the light bulb will go on, okay? But leading into, so her last problem, and even thinking about the one she did before, we're about to do the rule for it. And the rule is to add the opposite. And so what I want to show you with her chips right now is, she added in the opposite so that she could get her answer, okay? So when you move to the rule, so look at the top of your notes. It says subtracting integers by adding the opposite. So this is the important part. You're adding the opposite anytime you're doing subtraction now. So when we look at your paper, we shouldn't see subtraction anymore. We should see every subtraction change to addition, and then the next integer change to the opposite sign. So here's your steps for you. You keep the first integer. You're never going to change the sign on the very first integer. You change your subtraction sign to addition, and then you change the integer after the now plus sign to the opposite. Oh, that's a weird way. Okay. Change the integer after the plus sign into its opposite. I get after the now plus sign because we changed it. Get it, get it. All right. And then look here. Use the addition rules from lessons 1.1 and 1.2 because you've now created an addition problem. So let me change my color. All right, so if I'm looking at 8 minus 1 and I need to add the opposite, you don't touch this first integer of 8. Go to step 2, you change the subtraction to addition, and you change the sign on the integer after it. So right now it's a positive 11. That becomes a negative 11. And then you're looking at an addition problem. So you go to step 4 and you use your addition rules. First question you ask yourself is, are they the same sign or are they different signs? And because they're different signs, you follow your addition rule that says subtract the absolute values. So 11 minus 8 is 3. And you keep the sign on the bigger group. Negative 11 has more red chips. There's 11 red chips and 8 yellow chips. So your sign stays negative. So by adding the opposite, 8 minus 11 is really negative 3. Okay? Let's look at the next one. Negative 3 minus a negative 5. Go back and follow your steps right now of adding the opposite until you have this down. Keep your first integer. Change your subtraction to addition. And then change your next integer to the opposite. Well, what's the opposite of negative 5? Positive 5. And then what are you looking at? You're looking at negative 3 plus 5. And revert back to your addition rules. So same sign or different sign? They're different signs. So you actually subtract. 5 minus 3 is 2. And the sign on the bigger group is positive because 5 is your bigger group, so your answer is 2. All right, and then the next one, 19 minus negative 19. Follow your steps again. Keep your first integer, change subtraction to addition. You're adding the opposite. What's the opposite of negative 19? Positive 19. So you now have 19 plus 19. And what do you get when you add 19 and 19? You get 38. Okay? And that's positive. So two positives being added together gives you a positive answer. All right, and then the last question. Theo had a balance of -4 in his savings account. After making a deposit means putting money in, he now has $25 in his account. What is the overall change? I'm underlining all of the important stuff for us. So he had a balance of -4 in his savings account. He makes a deposit of $25 and they want to know what's the overall change. So one way to look at this is, what is the change? And change means, what's the difference? So if we write it out this way, and that means subtraction, doesn't it? So we're going to find the difference between where he's at now and where he started. So where he's at now is 25. So we're going to find the difference between where he is at now and where he started at. And he started at -4. So this is where he started at. Hopefully that makes sense. Do you want to add anything in?
I just want to go, because we know that a lot of you guys you're going to know the answer. Like, you're going to read this problem, you're going to know what the answer is. What we need you to be able to do is revert it back to the concept that we're teaching. So we're talking about subtraction of integers. That is now probably your task at hand, right? Is once you know the answer, what does that subtraction of those integers look like? Because we know that a lot of you would get the 29, but you would probably struggle a little bit in writing it the way that Cervantes did. So really follow suit on why she's using the language and thinking about, like, does my answer make sense in the end?
Right. Even when we first looked at this, we had to think back, because we go directly to the answer. We had to think back to how would we want you guys to set this up and figure out, okay, well, what are we trying to show you about the key words in the problem? And the overall change is one of the key words.
Yeah.
So the overall change means subtraction. So like Ms. Talati's saying, how do you set it up as a subtraction problem? Okay?
So then how much was the change?
The change, when you add the opposite, so follow your rules from up above again. So you keep your first integer, change your subtraction to addition, change the next integer to the opposite, you end up with 25 plus 4. So what was the amount of change? $29. Okay? Now if you think of a number line, if you want to check your answer, you can think of a number line either way, or even like a thermometer,
Yeah,
right?
that's what I was thinking, yeah.
So you could think of, if you're looking at a number line and you're at -4, let's say here is 0, wouldn't, and we're talking, let's do 25 over here and 30 over here. So if you're saying the change, he ended up at 25 and he started at -4, so it's asking you, what was the change? How much did he go up? Well, from 0 to 25 is 25, right? And then you went from -4 to 0, so that's 4. So it's really 4 and 25, which gets you the 29 change.
And we moved right on the number line, which is the positive, where we got the add the opposite.
Yes.
Yep. Perfect.
Okay. All right, so the next page is, oh, I thought you were done.
I got it.
The next page is for you to practice. Now look, we shouldn't just see answers written in here. We should see you changing this to add the opposite. Add the opposite and then follow your rules.
Hey, let's spice it up a little bit. Let's have them represent number 5. Let's see if they're really watching the video, right? Let's circle number 5 and number 6. Only 2 of the 10 problems we want you to represent with chips.
5 and 6?
Yep.
Okay.
And then the
Let's
rest
do
you have to
this.
use the rule like Cervantes did.
Model with chips.
Yep.
Or your, what? R's and Y's?
Yep.
Okay.
Okay. And then
All
you
right,
guys,
however you do it.
after that, you have a word problem. So give it a shot. All right? Have a good night. Day. Bye. Say bye, Cervantes.
Bye. Have a good